actually. Got an email from TV1 the other day saying, oh, gee, there's some extremes in Europe at the moment. Oh, it's quite concerning. And, well, would you like to come on and talk about what's happening? And I felt quite infuriated by the tone of this email. I wrote back and said, look, every media outlet in the world should have these points advertised every day. You know, we're causing climate change. It's getting worse. It will disrupt global society if we're not careful. We need to take action now. And the reply that came back was, oh, well, that's really interesting. So I'm going to be on breakfast TV tomorrow morning at 6:10 going over some of these points. At least that's my plan anyway. Anyway, look, I know we've taken quite a long time to get to this point, so I better get on with it, I think. So the title of my talk, Climate Change and How We Stop It. Actually, most of the talk is on the first line and not the second line, but I'll certainly have things to say about how we stop it. Right. Okay, here's my number one climate change illustration. This is a graph of how much carbon dioxide there is in the atmosphere, or has been, over the last 13,000 years, going back to 11,000 BC. The green and the red bits are from ice cores in Antarctica, the blue bits, observations in the atmosphere in Hawaii at Mauna Loa. And you can see, over this timescale, which is the sort of timescale the Earth operates on, 10,000 years or so, is how long it takes to melt an ice sheet, or how long it normally takes to raise carbon dioxide levels quite a lot, how long it takes for the deep ocean to change circulation and so on, usually. So on the scale that the Earth thinks about things, we've done dramatic stuff almost overnight. So coming out of the last ice age, the carbon dioxide level was rising up. It got up to what's called the pre-industrial level, bouncing around 280 parts per million a few thousand years ago. And then we started burning coal in the steam engines in the 1700s. And the problem with carbon dioxide is it just has such a long lifetime in the atmosphere, it just builds up. So most of that CO2 from WAPS steam engines is still in the atmosphere, we're breathing it today. So you pump this stuff into the air and it collects. And we're now about 50% above the pre-industrial level, up to a nearly 420 parts per million. And this stuff, as you all know, it's a greenhouse gas that is really good at absorbing the heat the Earth radiates. Just like a blanket on a bed is really good at absorbing the heat your body radiates, the same deal. So what's under the blanket in bed keeps warmer. What's under this blanket, that's the Earth's surface, also keeps warmer. The more of the stuff we add to the air, the warmer the surface of the Earth gets. That's the basic physics of it. So we're at a point now where we've got about as much of this stuff as there has been in the atmosphere for about 3 million years or so, so longer than we've been on the planet as a species. So it's pretty uncharted territory for us, just the composition of the atmosphere. But the really staggering thing about this graph to me is that half of the rise, which started in the 1700s, has happened roughly since 1990, in about the last 30 or 35 years. So as time's gone on, we've become better and better and better at adding this stuff to the atmosphere. You know, the flippant way of saying it is, well, half of the rise in carbon dioxide concentrations have happened in Taylor Swift's lifetime. And half of that have happened since she put out her first album. And, and you can have a chuckle about it, but this is saying to us, as time's gone on, especially since the Second World War, we have hit the climate system harder, we've hit the Earth harder, and our use of resources and energy and our impact on the world has become dramatically greater than it was, in my lifetime. But yeah, this acceleration of the rise in carbon dioxide is, I guess, indicative of the acceleration of humans' impact on the world generally. Okay, so the last Intergovernmental Panel on Climate Change report that I was involved in had a number of headlines, and this one, unsurprisingly, given how quickly we're adding greenhouse gases to the air, we find that recent changes in the climate are widespread, they're rapid and intensifying, and they're unprecedented in thousands of years. The composition of the atmosphere is unprecedented already in millions of years, but certainly many of the changes and extremes and so on we're seeing are very unusual. And climate change is affecting the whole globe. And as we all know, it's not just warming. Many things are happening. The whole climate system is changing. And crucially, as you make the climate warmer, the changes we experience just become larger. And the impacts of the extremes we experience become, at some point, too hard to adapt to, become unmanageable. All right, so we're adding this blanket, we're thickening the blanket over the Earth, and of course temperatures going up. Here's a graph of global average temperatures. This is the version from NASA in the US. That they all look pretty much the same. There's different groups around the world who do this. And you can see this is only back to 1880 now. It's about the start of when we had enough thermometers on the globe to give us a good estimate of global average temperature. Since the late 19th century, temperatures have warmed up a bit over a degree. So the vertical scale here, the zero line, is an estimate of the pre-industrial temperature. It's just the average temperature prior to 1900, which is only a 20-year period, but it's considered to be quite a good estimate. Anyway, relative to that, you can see the last 8 years, this is 2022, last year, the final bar there, are all more than a degree above pre-industrial. And the average is about 1.1, maybe 1.2. 2023 is going to come in warmer than last year. I doubt it's going to be a record, but next year in 2024 it will be a record warm year. So we see this trend really starting to pick up about the middle of last century, and it really is that sort of post-World War II period where we really started to push the climate system, and we see these trends really starting to stand out. The top of the vertical scale on this graph is 1.5 degrees, and that's the bottom of the range that the Paris Agreement talks about. So the Paris Agreement that was drawn up in 2015 at the COP meeting in Paris says that the countries of the world will do what they have to do to stop global warming at well below 2 degrees pre-industrial, and that we will all pursue efforts to stop warming at 1.5 degrees. And this was argued for mostly by Pacific Island nations, by small island states, because we know that sea level rise becomes very problematic if you warm things up much more than 1.5 degrees. Even 1.5 is no safe guarantee. Anyway, you can see, there's not a lot of room on the graph here. We are going to stop at 1.5. We'd better get on with it. I'll talk about whether that'll happen or not in a very minute. But yeah, we have sat around and watched this for decades without actually doing anything. But of course, last year was something like the 20th of a degree warmer than the previous year. You see these ups and downs, but the trend upwards is on the order of 100th of a degree per year kind of thing. We don't really feel that. What we feel is the extremes that come about because of this. So again, from the IPCC, it's indisputable. I like the fact that this latest report uses words like indisputable and unequivocal, not we're quite sure of, when it's coin toss or something. But it really is indisputable what's going on. So humans are causing climate change, and the way we feel it is these extreme events, which the most obvious ones are heat waves, and both ends of the scale with rainfall, both floods and droughts, are becoming more frequent and severe. I've got some guff on why that is. I think I might just skip over that in the interest of time. And maybe I can. Oh, no, that one. Hey, there we go. So skipping over the technical details of why these extremes are happening, let's just have a quick look at some of them. So this is not actually a map of temperatures for Europe for this year, this month. This is from last year. So what we've got here is the colour scale is a difference from average in the temperature. And this is for a day at the end of June of last year. And these pinky colours are temperatures 12 or 13 degrees above normal. And you can see most of France and so on. A lot of the sort of western part of Western Europe is very warm, as is Britain. And this was the day that the UK recorded its first 40-degree temperature. So unprecedented extremes happening, certainly over the big land masses which are warming fastest, such as Europe. And there was a report that came out recently that showed, or based on mortality statistics, that something like over 60,000 people died in this heat wave. So the normal number of people who die in the summer compared to how many died last summer suggests that it's that kind of number. Pretty amazing. I think heat waves are the most deadly aspect of climate change. Maybe they haven't been in this country yet, but worldwide they certainly are. And going on, and then coming forward to this year, this is a map from Spain, a satellite image of Spain from the 11th of July this month. And the black regions are where the surface temperature is more than 60 degrees C, which is, dangerously hot. And at the moment we have this kind of extreme heat in Europe, in the US, and in South Asia. So we've got these so-called heat domes dotted around the northern hemisphere. And this is the idea: as we warm the climate more, these kind of things just become easier and easier to achieve.
James, can I just clarify? The 60 degrees, that's ground temperature or air?
Great question, and I
confused about.
Yeah, I'm just not sure actually. I think it's air temperature. But land. Oh, sorry. Yes, it does say that. Yeah. Now, so that probably is the actual ground. So the air temperature would be about less, might be 55 rather than 60. Thanks. Good point. And when it's very warm, it also tends to be dry. So last year, this is not this year, this is last year again. This is the Loire River in France, with most of its water missing. Massive droughts in Western Europe last year, which seemed to go with the summertime heat waves these days. At the other end of the scale with rainfall, of course, is floods, and this is the part that we've experienced mostly in this country recently. This is a picture from Nelson from August of last year. Roughly at the same time of the heat waves were happening in the northern hemisphere, we've got this big atmospheric river, this big stream of moisture from the tropics hit the Golden Bay region dramatically. A few years earlier, similar thing happened in South Canterbury, and actually there's been big flooding in Canterbury just in the last few days. Again, a big hose of water coming from the subtropics just intersected with the land and dumped vast amounts of rain very quickly. The international airport terminal at Auckland got very wet at the beginning of the anniversary weekend in Auckland in January. And I didn't know, I saw this picture on social media and thought, what country is this? And, it's my country. Oh, I'm going to be there. It's getting this thing. Again, it's off the charts, things we've not seen before, big rainfall events. And here's, of course, the most obvious, most memorable this year, tropical cyclone Gabrielle. This is an image from NIWA of one of their workers. What does it say? Surveying the stock banks. Well, I'm not sure where the stock banks even are in this picture, but you can see the devastation. Massive amounts of water came out of the sky as this ex-tropical cyclone came by. It's estimated that something like 30% of that rain was there because of the warming that's already happened in the atmosphere. So we're making some of these events already marginal and manageable, I would say. Prime Minister stated, and quite rightly, that this storm was the worst to hit this country this century. Exactly when the next one might happen was very hard to say, but in the past there's been a big tropical cyclone kind of event every 30 years or so, so if we're lucky it will be another few decades. Yeah. But a really important point, I think, about this storm, which really pushed the conversation along about who pays for the damage and the restoration. This is an article out of the Herald just the other day saying, there's this bridge in Gisborne that's been destroyed. Should the locals who use it pay to have it fixed? Should the regional government pay? Should central government pay? Who pays? And I think there's no obvious answer to that, really. But it's this conversation that we need to be having nationally about what is the plan for covering the cost of these kind of events, which are only becoming more common, more extreme. So all of this grief's happening because of this, this 1.1 degrees of warming. But this bit, which we feel because we live in the atmosphere, is a tiny part of the story of climate change. It's a tiny fraction of the total heating that's gone into the climate system. There's a graph from the last IPCC report that demonstrates that. This is a graph of the change in the total energy in the climate system going back to 1970, 1960, or 1960, I think it is. And the vertical scale there, the energy units in zettajoules. Zeta is the prefix for 10 to the power of 21. So you put 21 zeros after each of those numbers. That's quite a lot of energy. And you can see these big segments here. These are parts of the ocean, the top 700 metres, then the bit down to 2,000 metres, then the deep ocean. And this purple bit right at the bottom, that's the atmosphere. So this our 1.1 degrees of warming is about 1% of the story, which is, you know, the total when we add it up for the oceans is over 90% of the story. So the oceans have taken up more than 90 times the amount of energy that the atmosphere has, which is good news for us because of all this has gone into the atmosphere and the temperatures have gone up, I don't know, 40 degrees or so. So going over sort of thing. So the oceans are slowing down the rate of change that we experience as we live in the atmosphere. But the oceans change very slowly, so we're locking in change within the ocean for centuries. It'll take a long time for the ocean circulation and so on to adjust to this amount of heat. And I think I've got a little indicator we have to consider really. So this much CO2 gives us the observed amount of warming, 1.1 degrees. We know how much we're emitting every year globally, and we know it's a pretty simple relationship actually between the amount of the stuff in the air and the global temperature. So we know you can work out if we take no action, there'll be enough carbon dioxide in the air to give us 1.5 degrees of warming in roughly 10 years, early 2030s. So unless there's some dramatic action like right now, I think it's pretty much locked in. Then we get to 2 degrees of warming, another 10 years after that. 3 degrees of warming, another 25, 30 years after that. So by about 2070, if we take no action, we could be at a level of warming that would have locked in melting of large amounts of the ice sheets, 10 metres or more of sea level rise. I don't know what the extreme rainfalls and temperatures look like, that much warmer. It would be at a catastrophic level, I'm pretty sure. Well before the end of the century. Or we take some action, right? 1.5 degrees of warming is also the amount of the warming you get if we reduced emissions by half this decade and got to 100% reduction at a zero, emission net zero by 2050, which is what our legislation in this country says we will do. We will contribute to global efforts to do this. And this is still the case. You know, if the globe could do this, then we would stop at about 1.5 degrees of warming. The question is, can we being humanity globally, can we do it? I'm really not sure. But whatever happens, you know, if the community of people on the globe are going to take this problem seriously, this decade, the 2020s, has to be the decade of action. If we leave it till the end of the 2020s and start thinking about reducing emissions then, well, we'll be at 1.5 degrees, we'll be well on the way to 2 degrees, we'd be looking at whether we can stop at less than 3 degrees. It would be dangerous by that point. So I really hope, and it's already, the middle of 2023, we're nearly a third of the way through 2020, we're over a quarter of the way anyway. Yeah. Let's see the blank action. Right. And yeah, the IPCC report had this statement about 1.5 degrees. And this was put out 2 years ago now. Immediate, so it wasn't immediate, unless there are immediate, rapid and large-scale reductions in greenhouse gas emissions, limiting warming to 1.5 degrees will be beyond reach. I was involved in the text of the chapter that this comes from, and the original draft just didn't have the will be beyond reach stuff, it just said 1.5 degrees is guaranteed. But it was softened a little bit because it's still true if there are immediate blah, blah, blah. It's still technically possible to stop warming at 1.5 degrees. I think realistically it's not going to happen. I'd love it to happen. And one of the really interesting things I think in the last IPCC report is encapsulated here. Yep, sure, yes, there's no going back from some changes in the climate system because like I mentioned early on, a big spike in CO2 like that, it would take 10,000 years for the globe to achieve something like that at least. And it will take 10,000 years to come back down again using the usual geological processes. So we've locked in some change for a very long time, but some changes could be slowed and others could be stopped by limiting emissions of greenhouse gases. And actually, it's pretty well understood now that if we stop emitting greenhouse gases, we stop global warming like right away, within a year or so. So we could stop the increase in the extremes and all the things that are getting in our way immediately. We could actually stop the warming from happening. We wouldn't stop sea levels from rising, we wouldn't stop ice from melting, but we'd certainly slow down the rate at which it doesn't happen. So, you know, we have all the power. We have a lot of power. We just need to use it. All right, so there's short and long-term changes. So long-term, yeah, mostly sea level rise and ice melt. Also ocean acidification. So the oceans are soaking up heat. They're also soaking up carbon dioxide, which turns into carbonic acid, which makes ocean water less alkaline, more heading towards acidic, which of course is bad news for marine ecosystems. And the short-term things, like I was just saying, with global warming and the change in rainfall and atmospheric extremes, we could stop that, just like that, if we wanted to. And then there are things that you hear about a lot in the media, a lot of people worry about, quite rightly, so-called tipping points, such as the loss of the Amazon rainforest. How likely it is, I'm not entirely sure, it's not my area of expertise, but people I know in Brazil, for instance, who work on this say that it's pretty likely by the middle of the century, perhaps. So if it happened, you know, it would turn into grassland, and that would totally change the climate of the tropicals part of South America, but also the whole circulation of the tropics. It would be a big deal. In some places with so-called Mediterranean climates, such as the Mediterranean itself, but also the southwest of the US and the southeast of Australia, parts of Chile and so on the verge of, if not already in, a state of so-called mega drought or desertification. There's a good indication that some of these regions will really dry up over the next few decades, and there's been big droughts in a number of these places. Thawing permafrost, releasing methane and carbon dioxide. This is already happening. It's unlikely to sort of blow up in our faces. It really doesn't look as though it's just going to go put this vast cloud of gas into the air. It's just becoming more and more of a problem and helping to warm the climate. Yeah. Loss of the West Antarctic ice sheet and associated sea level rise, which would be a few metres. Again, it's hard to say exactly where the threshold is, but we get to more than 2 degrees of warming. I think we're on that. The community thinks it's not. The collapse of the Atlantic deep ocean circulation of the Atlantic meridional overturning circulation, AMOC. What should have happened would, you know, this is the premise of the movie The Day After Tomorrow. But it would change the climate system, it would change the distribution of heat, it would change where it rains in the tropics. It would be a big deal if it shut down, but it's not considered too likely. Although, just in the last 24 hours, a new paper's come out, and this was a headline in The Guardian today. Gulf Stream could collapse as early as 2025 there, and it would bring catastrophic climate impacts. Yes, it would. And I've had a quick look at this paper, and they're saying that it could shut down sometime between 2025 and 2095, I think it is, with the best guess of 2050. So 2025 is the absolute earliest in this analysis. And I've read quite a bit of critique of this paper already. It's really based on statistics and some fairly simple models of the sort of chaotic nature of the climate system. I'm not saying it's wrong, but it's at the at the short end of expectations. And you know, the IPCC report, which I would still stand by, saying it's not likely to happen this century. And then last one, ocean acidification and deoxygenation. And these are already happening as well. And at some point, that could trigger an extinction event in the oceans, which of course would not be good news. Now, the bits I've got bolded here are the things that are considered very likely in the IPCC. All the others are sort of, we're not entirely sure. So they're all on the cards, but a lot of them we'll have to wait and see, I think. I would say the best thing to do is not push the climate system too hard. I don't want to find out where the threshold is for the loss of the Amazon rainforest, or the melting of the West Antarctic ice sheet for that matter. But yeah, the acidification, permafrost thaw, and certainly melting of ice in the West Antarctic are already happening. So it's obvious they're going on. But yeah, we might get into an irreversible situation with Antarctica in the next 20 or 30 years or so. Let's see. Let's have a look very quickly at the local scene. Here's a map. This is from the Working Group 2 report of IPCC, which is all about impacts and the whole chapter on Australia and New Zealand. This is projected change in mean annual runoff, so water availability really, river flows if you want to think about it that way. And what's shown here is for different scenarios of greenhouse gas emissions, and the numbers down the bottom are approximate global warming levels associated with those. The colours represent the change in runoff, so the blue regions are where you get more water and the orangey regions where you get less. So you can see as you wind up with warming, you get stronger and stronger signal. And broadly speaking, it becomes wetter in the west and south and drier in the east and north. This has been a pattern that's been on the cards for a long time. So just thinking about this region and, you know, a couple of examples with the sort of Paris Agreement future with nearly 2 degrees of warming, you know, you double the number of hot days that happen in this part of the world roughly. Very few frosts, not that you get a lot of frost in Wellington anyway, but if you live in Aotearoa or Karori, maybe you do. Rainfall change unlikely to be anything much at all, but of course the extremes, both the dry and the wet, are increasing. And something like 0.5 metre of sea level rise, plus the fact that vertical landward ground is sinking around here, so you could possibly almost double that number. So maybe that's manageable. And at the other end of the scale, you know, where we just burn everything like crazy and we get 4 degrees of warming this century, then you would have something like, I don't know, let's say 4 times the number of hot days. There'll definitely be no frosts even in Karori. And you'd have more rain in Kapiti where I live and less rain in the Wairarapa. So the east-west gradient in rainfall would increase. And yeah, how much sea level rise? Well, if it's this much warming, could be more than 2 metres of sea level rise by then. Lots of sea level rise. So, you know, that would be difficult to deal with. I think there'd be big changes in land use in this country if this kind of future eventuates. But I think even this sort of thing, it's still not as dramatic as what will be happening in a lot of other countries around the world. So I think we really need to think about, you know, what is happening internationally. We're a very strongly internationally connected country in terms of trade and travel and all the rest of it. What's happening with our trading partners and our offshore markets and just livability in places like Australia and South Asia? How many people are being displaced? How many are migrating or become refugees? What's the population of New Zealand in this future? You know, have we taken on 30 million refugees from South Asia and the Pacific? Maybe. I don't know. I think that the demographics, the whole way society could be operating at these higher levels of climate change could be dramatically different and very hard to predict. And, you know, it's not my area, but people are thinking about this for sure. The government and so on. Let's see if I can. Yeah. All right. So before we get on to how we solve the problem, just quick look at adaptation. What do we do to adapt to these changes? And yeah, so if you look near the coast, like I do, not totally near the shoreline, but close enough, we are talking about retreating from the coast, managed retreat from the coast. I think that's ultimately something that has to happen. You can build a seawall, but coastline is coming inland and we need to move with that coastline. And it's easy for me to say that, right? But it's a pretty hard thing to do, and there's a lot at stake and there's a lot of money involved. So something that I'm pleased to say is being talked about. And same story with floodplains. If you don't live near the coast, you probably live near a river, and there's problems there too, big floods. So again, don't build a seawall, don't build bigger stop banks, although these protective measures can be good ideas sometimes in the short term, but ultimately we need to move away from where the flooding is happening. And yeah, helping communities become more resilient, which to me means becoming good communities. We've become very individualistic, very separated from each other in recent decades, and I think well known the most resilient communities are the ones that talk to each other. You know who the people in your street are, you know which person might need help if there's a flood or a power cut or whatever. We look after each other, That would be really useful in terms of general resilience. Okay, mitigation. Finally, how do we stop this problem? Well, we've got to reduce emissions, right? We've got to get emissions down to zero. And the latest IPCC report said emissions must peak before 2025. It's the middle of 2023 now. So in the next year, roughly, if we're going to have at least a 50% chance of stopping 1.5 degrees, we've got to get global emissions starting to go down before the end of next year. And just again, we're the ones adding this stuff to the air. We are causing this problem. We are hurting ourselves deliberately. Maybe it was accidental 100 years ago. We know what we're doing now. We have all the power and we've got all the skin in the game. We can take action. And, we don't need to wait for some magic technology. We have a lot of technologies already available that would reduce emissions a lot. And this is a table from the IPCC report, which nobody can read, not even me, but each bar is an opportunity to reduce emissions, like wind energy, solar energy, reducing energy use in buildings, etc., etc. It all makes sense. And it covers most aspects of how we live our lives and our economies. We have a lot of technology using. We are using some of them already, but we can roll out more if we set our minds to it, for sure. In this country, and actually around the world, I'd say, it's similar. This is advice from the Climate Change Commission. We need to make a big push on the transport sector. This is where most of the growth in carbon dioxide emissions have been in the last 30 years. So we're all driving cars a lot more than we used to 40 years ago. We need to, one, get people out of cars, have much better public transport, active transport, that's, walking and cycling. Electric vehicles and the infrastructure to charge them, etc., that all needs to be pumped up. And we could reduce emissions in this sector dramatically if all of that happened. And then the sector that actually has the biggest CO2 emissions in this country, and in most countries, I think, is the heat industry and power sector. And a lot of the problem there with burning coal, for heating, or for drying out milk, making milk powder, or running the power station, etc. If we can stop doing that and bring in renewables, turn off Huntly and have enough batteries and solar panels and wind turbines to cover the load, great. And in the land sector, that is farming, part of the Zero Carbon Build Act, says that we will get to a 10% reduction in methane emissions this decade and a 24 to 47% reduction by 2050. And the reason it's not as dramatic as for carbon dioxide is because it only stays in the air for 10 or 15 years. So you start turning the tap down and the amount in the atmosphere starts decreasing quite quickly. And yet we can plant trees, but as has been discussed a lot lately, it's not a long-term solution, but it does buy us a little time. So as trees absorb carbon dioxide. And what can each of us do? Well, I think everyone can play a role if they wish to. What everyone wishes to. Anything that makes a difference makes a difference. If you want to ride a bike instead of driving a car, have clothes like the t-shirt that's lasted quite a few years, obviously, excellent stuff. Don't get into fast fashion. Either make or buy clothes that are going to last a long time. eat less red meat, use public transport, etc., etc. You know, I have to say a lot of this is depends on privilege. You know, some people can afford to do a lot of these things, and some people just cannot afford to do any of them. Not everybody can go out and buy an electric vehicle, for instance. And I think it's a real issue. You know, it's hard work to be green at the moment. We need changes in economic settings to make it easier for everybody and to support everybody. But in the meantime, you know, like I said before, talking about the problem is in a sense one of the easiest things we can do, one of the best. But you know, this is a global problem, and it's really governments who can change how economies operate that we need to see action from, and they can help steer business in the right direction. And you know, if taking action on climate change is kind of the default thing for people to do, if it's easy to do, to have a low carbon footprint, then everyone's going to do it. Right? Might even be the cheapest thing to do. It'd be brilliant if we could get government to set things up to the point where some of these things can be just done by everybody. So get out there and tell the government what they need to do. You know, go and bang on the door of Parliament. At least send an email to them. And I think cooperation is crucial, both internally, you know, in your own neighbourhood, your own whānau, your own workplace. But I think international cooperation is important too. You know, countries sign up to these agreements like the Paris Agreement, but there's not really that much working together from one nation to the other. There is some, but not much. And it's a time when, you know, nationalistic politics is on the rise, and we're sort of moving away from cooperation in a lot of ways, which is a bit of a worry. But the more we can work together, you know, the more power we have, basically. So when there's a march on Parliament, such as this one just before COVID in late 2019, yeah, go on. Or organise one if there isn't one going to be happening soon. I'm over there somewhere, just around the corner, I think. But I was at this march, and it's, you know, from a psychological point of view, it's really good to do these things. It helps you feel empowered and helps you keep going, I would say. But just sort of finishing off, you know, how did we actually get into this situation? I said earlier on about the increasing load on the Earth system. And this is mostly about growth, right? Economic growth is basically bad news. So neoliberal economics came along. I think Naomi Klein made this point that at the time we started to understand about climate change, it was right at the time that, you know, Reaganomics and so on was becoming the fashion. And we really ramped up our use of stuff on the Earth, so going in the wrong direction very fast. But of course, you know, all growth has to stop. If we're going to be really sustainable long term, then we have to stop economic growth. We also have to stop resource use growth, population growth, land use, exploitation growth, etc. You know, nothing can grow indefinitely on a finite planet. And maybe the answer, is this so-called degrowth idea. And I read this really good book a few months ago by Jason Hickel. If you haven't read it, read it. It's very cool. I don't know that I like the word degrowth. It sounds more negative than the idea actually is. It's more about rejigging the economy and reallocating resources in a way that makes a lot of sense to me. I've lived in a growth economy all my life. I find it hard to imagine a non-growth economy, but, you know, donut economics and all the rest of it, there's a lot of thinking out there about ways that we can do this. I think something we really need to move towards. So what can we achieve? Well, you know, nothing's guaranteed for the future. And like I said before, we've got 100% of the power in this problem. So in my mind, it's not game over, you know, climate change isn't going to kill us off. It really is game on. We need to be on this game. We need to be taking action immediately and for the foreseeable future. But on the other hand, you know, the status quo has a lot of power and a lot of money. And our fossil fuel-based society has been built up over more than a century. It's not easy to just turn it off. So how long is it going to take to break this economic paradigm that we live in? And how long to dethrone big oil, a phrase I like to use? I don't know. I mean, these things have to happen, I think, if we're going to save the future. But it's not obvious to me right now how and when that is going to happen. And I guess if you want some really bad news, I discovered this blog site not quite recently, The Consciousness of Sheep, by a guy called Tim Watkins, and he's one of these people who's, a galaxy brain. He takes all sorts of ideas from all over and joins dots very convincingly. And this story, A Predicament Restated, his post from last week. It's a pretty long read, but it tells the story. And he makes this point too that I've said before, post-World War II, the post-World War II party, accumulated world industrial output in the 20 years from 1953 comparable to the whole of 150 years before 1953. Again, the idea that we've ramped up our use of stuff dramatically in recent years. And he does ask the question, how much can actually be achieved? And there's a big gap, a big chasm between what we think we can do in theory and what we can actually do in practice. Again, I don't like to say things like that, but I think it's just quite right. So if you've got a bit of time, have a look. Just Google Consciousness of Sheep. I'm sure that'll or Our Predicament Restated. So what's the prognosis? Well, I think it is a race against time. We can still stop climate change at a level that is manageable in most countries most of the time. So can we stop emissions in time to stop the unmanageable? I think the answer is yes, still. And how do we prepare for the fairly unmanageable? That's the adaptation part. Well, people are onto that now. And then the question is, how good could it be if we do take this decisive action? We switch off all the coal-fired power stations and the petrol-powered cars. Air quality would be fabulous. We'd save a lot of lives just from stopping respiratory illnesses to a large extent. So, it could be great, the future. It could really be clean and green. And if you want an inspiring story about the future, read this book, which you may all have read, Kim Stanley Robertson's book, The Ministry for the Future. Yeah, Barack Obama, I like that a lot. Great. Yeah, a novel that presents a rousing vision of how we might unite to overcome the greatest challenge of our time. Yeah, and it is optimistic, but it does tell a nice story, I think. And then there's this book here, which just came out recently. It doesn't quite take the same line as this book, but I do present it towards the end. Some of these possibilities I've just talked about. And I do believe if we get on and take the action, we're talking about the future for all of our children, for all of our descendants, and it strikes me as it's important enough to really put it into. Anyway, final slide then. So the summary, and this is from a colleague of mine in Canada, Kimberly Nicholas, this great piece of paper she wrote, I think after the publication of the 5th assessment report of the IPCC. This is her summary. It's warming, yeah. It's us, we know this, we're sure about it. It is seriously bad. But the crucial green line at the bottom, we can fix it. And that's always been true, it's still true. And I would like to think that we could cross that can and we are fixing it. So, don't give up, don't despair, get active, feel positive, get engaged in some kind of action. And that's very empowering, I think. And if we all work together, we can actually fix this problem. Like I say in the book, imagine a world without climate change. And I talk to school students and they say, it's always been there. There's never been a world without it, as far as they know. And actually, I could say that's the same for me. I just wasn't aware of it until quite recently. But yeah, it would be brilliant to stop climate change. It would really be the best thing. So I hope we do it. There we go. Thank you very much.
So a huge thank you, James. It's a real honour to capture your time and your wisdom, and we do have time for a few questions. I'm so sorry about the technical issues at the beginning. It's just part of the course these days, apparently. So yeah, we'll just throw the mic out, really. We've probably got time for a couple of questions from the room and from the online audience. I can see a couple of hands raised. Ian.
James, the slave traders were stopped because the government borrowed money to pay them to stop trading, which I've just paid off now.
Right, yes.
And it's been suggested that we need to borrow money, pay off the oil companies to stop them in a very, very profitable.
Yeah.
What are your thoughts on that?
Sure, boy. Maybe. I mean, yeah, the oil industry, the fossil fuel industry has a lot of money, right? It's the most profitable industry in history, apparently, and making billions of profit these days. Maybe they need to be paid off to help to persuade them to stop drilling. I like that idea, but I wonder about the consequences. I think money needs to be invested in alternative energy sources. If you paid oil companies to stop drilling, let's say, and you dried up supply, well, that would certainly force some action on renewable resources. Yeah, so I like the sound of it. I'm sort of thinking about the consequences, but yeah, maybe something like that is part of the mix, actually, because that's something that I worry about or think about. That we have this economic system as it is. You can't just turn it off tomorrow, do something else. That would wreck people's lives worldwide. So you do have to ease the oil companies out of their routines. You have to ease all of these carbon-intensive activities towards something that's less intensive, has zero emissions. And yeah, money has to be spent for sure. I don't know. I mean, the oil companies are already being subsidised hundreds of millions of dollars a year, right? Trillions. It's not as though they are getting free pass from taxpayers at the moment.
Well, it was interesting with the slave traders. Some of them took that money and put it into new activities that were more acceptable. Some didn't.
Yeah, some. Yeah. So yeah, I mean, it's a good analogy. It sounds like. I don't know if anyone's talking about this, seriously at a government level, or is it an idea that's just been sort of been floated, or is it an idea that you've had recently, or what's this great?
The thing is that it's very hard to get up something you've done for a long time that you make lots of money for.
Yeah, exactly. Right. Yeah.
And it's like, why stop?
Yeah, they're destroying the world. But in the meantime, the sun's still shining outside, and I can go and have a coffee, everything's fine. And that's the problem, our vision is pretty short term and pretty local, and it's very hard to even see what's going on.
We've got a question from Letitia Lowry. You've sort of covered it. Kia ora, James. Do you have comments on the role of adaptation versus mitigation and how to balance these?
Oh yeah, and I didn't. One of those things even though I ran late, I skipped a few things. Yeah, and as my colleague Judy Lawrence always says, mitigation and adaptation have to work together. And adaptation measures we have to be sure we're not locking in, we're not maladapting, and we're not locking in high emissions infrastructure. So we need to be thoughtful about how we adapt to make sure that it actually helps mitigation as well. So you restore mangroves at the coast, for instance, and that actually helps to absorb a bit of carbon dioxide. So you're doing a wee bit of offsetting as well as adapting to increasing sea levels. So yeah, it's something to think about for sure, and we don't want to be in the situation which is often the case where one arm of government over here is doing the adapting and the other arm over here is doing the mitigation, and there's no conversation between them as to how they can work together. We can definitely work together on that front.
I like that. Any in the room? Yep, please.
I've heard a saying you have to measure it to manage it. I was wondering, what do you think these two roles lie under? Is it a government role, private company, or research institute, especially when it comes to inventory and vision modelling?
Yeah, no, that's a great question. And you're quite right. You've got to measure things to manage them. And it is, well, the present situation is there are organisations like, Toitu, ECOS and so on that will help whoever, businesses, individuals, reduce their emissions, or will measure emissions from a particular organisation or sector of the economy and then help those groups reduce. I don't know whether there's a role for government in doing that nationally. I mean, under the United Nations Framework Convention on Climate Change, the government has to report its inventory of emissions, which MFE does. And that, that will continue. That's a good thing. The Climate Change Commission has a monitoring role, from now on. The first emissions reduction plan and the National Adaptation Plan are out. The Climate Change Commission will keep track of whether what the government says it's doing is having the effect it's supposed to have. So that's a monitoring role at the government level. But my feeling is that kind of measurement and mitigation works most effectively in a more local level. So businesses do that kind of work, help individuals or businesses themselves reduce their own emissions. Yeah, I think it works well fairly locally, and it is, it's a business opportunity. So people who want to get into doing that kind of thing, it's been quite successful for some of the players. But yeah, I think it would be a bit unwieldy for government to do all of the but the government has to enforce what the movement says.
I've got a question, but I've scanned the audience. Any others? If you were the boss of the world,
Yeah.
I thought, what rule would you set tomorrow?
I love these sort of questions. First thing that springs to mind is, an absolute ban on any exploration of, any new coal mines, any new oil wells, any new fossil fuel reserves. Just no. We've already got more than enough to cook the climate system with what we know about now. So that would be one. And I guess two, I'm not an economist or a finance person in any kind of way, but there must be ways to free up private sector money, private sector resources as well as government resources, just to put money into innovating around reducing emissions. I often think about the COVID situation. One of the things that happened in 2020 was medical researchers around the world suddenly had a whole lot of money thrown at them, get on and find a vaccine for this thing. And it was conveniently, there were things on the shelf that were close to the answer because of previous pandemics, or previous outbreaks at least. So they were able to make progress quickly, but I've heard it said that one of the reasons they did make progress quickly was because they didn't have to put in an application to get some money to do the research. They could just go and do it and get the clinical trials going while they're doing this and this, and it all happened much faster because they had plenty of money behind them. So I think, if you put all of the scientific minds in the world to thinking about how to find better ways to generate electricity renewably or better ways to store it in batteries, etc., I suspect we could make a lot of progress quite quickly. I mean, we've made a lot of progress as it is, but it's been around the edges, I think, of everything else. So I'd like to see some massive injection of money into climate action, basically, climate solutions.
Yeah.
There we go, just infinite money, no problem.
Thanks, boss. Yeah. I mean, during COVID, I got the idea of a planetary sort of spring clean when we weren't allowed to fly, and everything kind of suddenly got really fresh and clean. It's like, what if we just said, all right, December, the world shuts down?
Well, a bit like Carlos Days, you have fossil fuel-less months. I mean, it was really remarkable, wasn't it, the lockdown in this country, at least, well, all around the world, all the skies cleared and you could see the mountains and all the rest of it everywhere. And it was really good. For me, again, that's a privileged person speaking. I could work from home, I continued to get paid, all the rest of it. Didn't really affect my lifestyle very much, except that I had plenty of time to wander around my neighbourhood, and I really felt more connected to the whenua where I live, which is sort of a sad commentary on how I live my life, but it is important, and I think that's a really good idea. You have a period of time every year where you don't drive your car, you don't fly, you don't do anything much.
Sounds good. I want to give a bit of attention to the chat online, and I know we're nearly at time. Alex Pizza asks, would it be possible, I've never asked this question, would it be possible in theory to have a warmer atmosphere without such extreme weather events happening all the time?
That's a really interesting question. No.
Yeah, there you go, Alex, no.
I think, you warm the climate.
What did we say, please?
Yeah, pretty pleased. The answer's still no. You're bound to get more high temperature extremes in a warmer climate. There's no way around that. Unless you could reduce the variability of temperatures. But how you do that, the answer's still no. And rainfall extremes, they happen because the amount of moisture in the air goes up as you increase the temperature. So you're bound to get heavier rainfall events in a warmer climate. And evaporation works better in a warmer climate, so you get dry conditions setting in more easily, you get more droughts. And this, it's really basic physics. I don't think there's any way around that. It's a very nice idea, but it's not practical.
What about if the government just said we're going to have reduce the amount of oil that comes across the border and the amount of cows that are going to get killed? Say by 10% per year, because then people would find ways around it. For example, they would come to work 3 days a week instead of 4, and all that sort of thing, or they would share a car with their neighbour or something like that. I mean, wouldn't that be a pretty simple, obvious way to do it while they're messing around setting up other systems? Yeah, I like that idea, and partly about, reducing the supply of fossil fuels for us. We hear a lot about reducing demand, but if you reduce the supply, that's a pretty effective way of people have to think differently. So, that's a way of forcing people to innovate around what they're doing, whether that's, working from home or whatever. So, governments mandating reductions in the use of fossil fuels, mandating reductions in the number of cows on the land. Great. I don't know of a political party that would actually stand up and do that. That's your boss is wrong.
Let's just imagine that I'd be a big supporter of that,
This can be quite a sort of a heavy topic when you really start thinking about it and being in it all day, every day. So I'm just wondering if there is something that you've seen that you can reflect on that gives a bit of hope.
That's another great question. And a colleague of mine in a panel discussion the other day was asked this, and she gave a great answer. She said, look, there's any number of little community groups out there, people working together, like I say, cooperating, to make some positive change in their own bit of their community. And she didn't give me a list of the examples. I'm aware of one on Kapiti Coast, but she was making the point that there are people out there on the ground working to make things better, basically. And that gives me hope. The students I meet at Victoria University give me hope. Most young people are certainly aware of the problem, and they're really keen to find out more and then get out there and make the change we need to make. So I feel hopeful because of the activism, really, of people these days. Compared to 10 years ago, there was no Extinction Rebellion, there was no school strike movement. There was 350.org, there were NGOs doing things, but the scale of that has really ramped up in the last few years. And I applaud people who glue themselves to motorways. I'm not going to do that myself, and I understand why some other people might be quite upset, but that's the point, right? It helps to change the conversation. So all of those things give me hope for the future. The thing that worries me is, like I said before, it's a race against time. We need to take the action. Right now would be good, and waiting until everyone's kind of got on board with the ideas, we just don't have the time for that. So I'm hopeful the way things have changed the last few years, the attitudes have changed, but I'm also still very concerned. You're quite right. I'm thinking about this all day. It can take a bit of a toll.
So I'm part of the Whakamoa Bay Climate Action Group.
Oh, right.
So, I'm not sure if that's the one that you were talking about.
No, actually, but carry
There's
on.
another one, and that started with 2 workshops that happened over a period of like 3 months, and people show up. Like, it's a very small community. We're really, really concerned and wanting to be involved, referrally to be involved with what they can do at the household level to change, and even trying to actually measure the
The group I was thinking of that I've had a bit of involvement with is Low Carbon Company, which is based in Aotearoa mostly. And they've worked with the council and achieved some things around, reducing emissions from council vehicles and that kind of thing. They've been involved in tree planting exercises in Elizabeth Park, restoring wetlands, etc. So they've taken a bit of local action, or they've facilitated it, and they've talked to the council and helped to move things along. So that kind of things, I think.
Thank you so much, James, for coming. And as Aotearoa mentioned at the beginning, sorry, I should understand it. James is only a few days away before heading overseas to do this amazing research overseas. So we're so lucky and privileged to have got his time today. If it had been me, I would have said, no, too busy, too stressed, whatever. But he made the time because these conversations are important. And I also would like to say thank you for being so honest about our predicament. And thank you for talking about growth and the proposition that degrowth might be the answer, and that ultimately this is a problem of consumption, right? Yeah. And it's also a little bit daunting when we realise that climate change is only one example of our overshoot of planetary boundaries. So a technical solution, even if we miraculously found one for climate change, will not solve all the other issues that are caused by overconsumption, which has been fueled by fossil fuels, as you so rightly said. But thank you so much again for coming in and spending time with us, and we wish you so well for your research.
Thank you.
And when you come back, we'll have it all sorted, James. Yeah. Promise.
That's the plan,
Yeah. Excellent. Thank you.
Yeah, all right.